Aha, I love it. I love this one. I love this one, and I include this one because it's really important to understand that this is the case, specifically about squared numbers and vice versa. Okay, so for the following true conditional statement, they're telling us that the original conditional statement is true, this. If x equals 9, then x squared equals 81. And we know that that's true. If you have 9 for x, squaring it will give you 81. Totally true. Okay? So for the following true conditional statement, write the converse. So the converse is to switch the hypothesis and conclusion. So this would be the if statement. If this, if x squared equals 81, then, and what was the hypothesis is now the conclusion, then x equals 9. So let's get rid of any ones that don't fit that don't switch the hypothesis and the conclusion. Well, so far it looks like the only one that hasn't switched that is that one. Okay? If the converse is also true, combine the statements as a biconditional. Well, is it true? So here they say it's false, here they say it's true, and they give you two biconditionals. Let's look at it. Excuse me. If x is 81, then y is 9. If that's true, then the biconditional can have this in any position. So x equals 9, if and only if x squared equals 81. X equals 81, x squared equals 81, if and only if x equals 9. These are the same. So because it's a biconditional, it doesn't matter which you listed as the hypothesis and which you listed as the conclusion. It's if and only if. There's no, they lead in both directions. So actually, if you understood it, you would understood that C and D, those are actually both the exact same thing. A biconditional can be written with either one as the first thing listed, and either one as the other one as the second listed. Okay? And the fact is it's not true. It's actually not true. If x squared is 81, then it's not true that x equals 9. Okay? So if something's not true, we should be able to come up with a counterexample. So if x squared is 81, then x is 9. No, it's false. What's the counterexample for this? X equals negative 9. If x squared is 81, it could have been that x was negative 9, because what's negative 9 times negative 9? It's 81. So if you got some number squared was 81, did it have to be that that number was 9? No. The number that you squared to get 81 could have been negative 9. Always remember that when you square root a positive number, the negative could also be the thing that you got, because negative times negative is positive. So that's another way of getting to 81. Absolutely essential piece of information for you to know in mathematics. Okay, now, number 43. Is the following definition of equilateral triangle, is it reversible? If it's reversible, that means that we can swap the hypothesis and conclusion and write it as a biconditional. Okay. An equilateral triangle has three congruent sides. Okay. So we could say that if a triangle is equilateral, then that triangle has three congruent sides. Can we reverse that? If a triangle has three congruent sides, then it's an equilateral triangle. Yeah, well, that's what equilateral means. That's the definition of it. So if it has three congruent sides, it's equilateral. All equal, three equal sides. Equal, equilateral side. Equilateral. Okay, so, yep, that is reversible. So we can, the reverse is true, the reverse is true, the reverse is true. D is not the case. Let's get rid of D, cross it out, eliminate it. You can see that I'm always going through and eliminating things that I know to be untrue, because that narrows our number of possible choices left. So crossing something out as soon as you know that it's not true means I don't need to consider that one anymore. Just be sure you know. Okay. The reverse is true. So it says write it as a true biconditional. And which one? These don't actually write them as biconditionals. That's just another conditional statement. That's just another conditional statement. So those don't actually do what's being asked, so we can eliminate those. And let's see. A triangle is equilateral. Triangle is equilateral if, and only if, it has three congruent sides. That's great. That's what we want. There it is. Since it asked us to identify whether it was true or not, and if it was true, write it as a biconditional. The only, like B and C, determine that it's true, but then don't write it as a biconditional. So that doesn't even meet the requirements of what the question's asking you to do, so you know that it can't be that one. But the reverse is actually true, so it can't be D, and there you go. Okay. Oh, and by the way, let's mark up here for number 42 what it is. Okay, it's false. X could be -9. Okay.